As we learn more about space, we become increasingly convinced of Earth's uniqueness. Its reliable and magnetic field, dense atmosphere rich in oxygen, and abundance of water are rare qualities. However, numerous chance events have made it comfortable for human habitation. Let's take, for instance, Earth's axial tilt of 23 degrees. If this number were smaller, like Jupiter's, there would be far fewer agriculturally suitable lands on our planet. The amount of heat received from the sun would remain constant, turning the equator into a scorching inferno and the poles into even colder deserts. Warm and cold air masses would remain static, leading to no seasons, temperature variations, or fluctuating humidity levels. Consequently, agricultural yields would be significantly reduced, and this is just one factor. There's also atmospheric pressure, forests, ocean currents, and many other crucial elements that sustain life on Earth. Thus, it's tempting to proclaim Earth as the most comfortable planet in space, with nothing better possible. But what if there is? Mathematics, physics, and astronomy can be ruthless in asserting that there might be planets in space more suitable for life than Earth. Back in 2014, Heller and John Armstrong even introduced the concept of a superhabitable planet. According to their definition, this planet or moon possesses characteristics that allow for a more diverse flora and fauna than Earth. But how is such a thing possible? Well, to answer that, we should look not only at the planet but also at the star it orbits. The Sun is a typical G-type yellow dwarf of the main sequence. While we appreciate its comfortable conditions for life, stars of this type are not the best for life. That distinction belongs to Class K stars, which are nurturing and caring luminaries for their planets. They are usually cooler than the Sun, but their suitability for life is not solely about temperature. The star's temperature affects the radius of its habitable zone. The key features that make Class K stars ideal are their activity and lifespan. Our Sun is a unique compromise between large and small, hot and cold stars, but Class G stars have shorter lifespans. The Sun is already 4 billion years old and gradually increasing in brightness. In about 1 billion or 2 years, it will transform into a red giant, inevitably wiping out life on Earth. On the other hand, Class K stars can live for about 40 to 70 billion years, giving hypothetical life around them significantly more time to evolve without facing global cataclysms. This longevity advantage is another drawback of Class G stars. Our Sun's instability subjects Earth to alternating ice ages and global warming. Just a few tens of thousands of years ago, glaciers extended to central Germany, but life flourished nonetheless. Orbiting a Class K star provides better protection against stellar disturbances, allowing life to develop for tens of billions of years, reaching incredible heights of advancement. Moreover, the universe contains many more Class K stars than stars like the Sun. While G-type stars constitute only 6% of the total in the Milky Way, Class K stars make up 13%, thus increasing the chances of life's emergence around them. Let's continue and talk about sizes. In planetary sciences, they matter significantly. If our Earth were 10 times larger, the pressure created by the liquid mantle would increase exponentially, likely causing the iron core to solidify. Along with it, the magnetic field would vanish, and instead of the auroras, we would observe people's faces dying from radiation. Added to this would be constant asteroid bombardments, attracted in swarms by the massive planet, and increased volcanic activity. After all, more mantle means more attempts to break through the surface. Precise models are challenging to construct, but scientists generally agree that life on such an Earth would be possible but not very diverse. Gravity would also play a role, making us all 10 times heavier and introducing numerous other lethal factors. The same can be said about a smaller Earth. Here, problems arise without much effort. Less gravity would mean fewer forces to retain the atmosphere. We already have challenges in this regard today. In 2009, NASA calculated the rates of atmospheric loss on Venus, Mars, and Earth, and surprisingly, Earth loses its atmosphere the fastest. More precisely, around 90 tons of matter are lost daily. Comparing this directly to Mars isn't entirely fair, as Mars is smaller and has already lost most of its atmosphere long ago, but the fact is clear. If we magically reduced Earth's size, its atmosphere would dissipate rapidly, and any talk of life would be irrelevant. Nonetheless, there exists a golden mean between the two extremes. A planet that is 1.5 to 2 times heavier than Earth can indeed boast a couple of advantages. Firstly, with twice the gravity, the atmosphere would be denser. This automatically reduces the amount of solar radiation and leads to a couple of pleasant side effects, such as erosion and leveling of the landscape. The depth of the oceans would decrease, leading to greater biodiversity in marine life, as it thrives in shallow waters. While tectonic activity might increase slightly, it would be balanced by vast areas for settlement. On a larger planet with smaller oceans, there would be enough habitable land for everyone. A denser atmosphere would raise the temperature by 5 degrees, coupled with an abundant oxygen supply for life, creating an environment akin to paradise. However, life would need to adapt to the increased gravity, and trees might not be as tall. But according to scientists, the advantages of such a planet slightly outweigh its drawbacks compared to Earth. What else could make a hypothetical exoplanet better than Earth? A much greater number of continents. When 300 million years ago Earth had only one supercontinent, Pangaea, its center was sparsely populated desert. The farther from the ocean, the drier the climate. Even today, the centers of Eurasia, such as the Gobi Desert, and Africa, like the Sahara, are not particularly hospitable. Space.com consulted astrobiologists, and unanimously, they claimed that the more smaller continents, the better. It would prevent remote areas far from the ocean, promote more ocean currents, and increase the diversity of life on the planet. Look at isolated Australia with its unique spiders and kangaroos. The world operates in a way that the strongest survive, and the further apart life is distributed, the more chances weaker species have to survive and evolve into something interesting. As you can see, humans are such ungrateful beings that instead of expressing gratitude for Earth's imperfections, they have dedicated hundreds of scientific articles to find a better planet. Indeed, this endeavor has had variable success. In 2020, Dirk Schultz published a resonant article with a bold title, 24 planets that could be superhabitable, meaning they have conditions better than Earth. Unfortunately, upon closer examination, it turned out that 23 of them did not meet the expected characteristics. Since then, we have not made significant progress in finding habitable planets. Scientists often use mathematics to calculate orbits, planet masses, and hypothetical atmospheric compositions. However, as we already discussed, life is a delicate thing, and too many things can go wrong. Concrete evidence of a super-Earth's existence is necessary. Currently, one of the primary candidates is Kepler 442b. This planet checks almost all the boxes on scientists' checklist that we mentioned. Firstly, it resides in the habitable zone of a K-class star. This star is about 40% lighter than the Sun, but Kepler 442b is closer to it. The planet's year lasts only 112 days. Admittedly, Kepler 442b receives around 30% less warmth from its star compared to us. However, two remarkable details compensate for this: Kepler 442b's size. It is about 30% larger in radius and twice as heavy as Earth. Consequently, all the points regarding a dense atmosphere, small oceans, and ample living space are fulfilled. The greenhouse effect from the dense atmosphere theoretically offsets the difference in received warmth, making Kepler 442b one of the most promising candidates for hosting life. However, the planet is located 1,206 light-years away from Earth. In theory, James Webb's capabilities should be sufficient to observe it more closely. But even if the telescope discovers something noteworthy, with the current level of communication technology and space travel speeds, we won't be able to verify it soon. The only consolation is that K-type stars can sustain life for much longer than Earth, leaving plenty of time for our descendants. Additionally, one of the candidates for hosting life is the TRAPPIST-1 star system. Within its habitable zone, there are 4 planets, one of which has particularly drawn scientists' attention, TRAPPIST-1e. This exoplanet is a unique world with physical characteristics closely resembling Earth. Mass, radius, gravity, density, and even temperature are very similar to Earth's. However, there is a significant problem: the star in this system is incredibly cold, with a mass 10 times smaller than the Sun, which means that the habitable zone is much closer to the star. TRAPPIST-1e's year lasts only 6 days, and its proximity to the star exposes the planet to constant bombardment of radiation. Nevertheless, if life somehow learned to endure such conditions, it could exist for billions of years, as brown dwarfs are incredibly resilient, and their lifespans are even longer than those of K-type stars. Therefore, ruling out TRAPPIST-1 from the list of potentially habitable planets would be premature, especially since this world is located just 40 light-years away from Earth, and the James Webb Space Telescope will undoubtedly explore this system. The truth is, our knowledge of life is incomplete. We have created bombs capable of wiping cities off the face of the Earth, yet we cannot create even the simplest single-celled life form. Life remains a mystery that has not been fully unraveled, and thus any analyses of planets are inherently speculative. They are based solely on our observations of Earth, but space is vast, and life may exist in forms we cannot even fathom. Whether scientists of our generation will discover life in space remains an open question. Leave your opinion in the comments. Thank you for watching. See you soon.